session. Oh, thank you for that. So welcome everyone to our grade 11 math session. My name is Batseba Nkhabani and I'm your math teacher. Okay, so welcome guys. Thank you so much for joining our session. So my name is Batseba Nkhabani and that's my email address. Please note down my email address. So it's my name and surname at gmail.com. Okay. So it's my name and surname at gmail.com. And you are welcome to send me questions after the session. Okay. So during the lesson, just make sure that you're on mute and your videos are off. And also, we'll have questions at the end of each example or exercise, or if we're doing problems, then we'll do questions after that. Okay. And then you can also, like I said, you are welcome to send me an email after the lesson so that I can help you further. And another thing is, we only have math-related questions in our charts. Okay, so we only have math-related questions in our charts. Okay. These are some of the links I use. So I use the Siavila textbook. You can use any other textbook. And we'll do questions from our DBE website so that we can improve our problem solving skills. Okay. And also, if you missed videos or you just, so if you missed a video or you just want to go through a lesson that you attended, you can go to our YouTube channel. So you go to YouTube and then Africa Teen Geeks and search for your grade and subject. Remember, it's not only math sessions, so you can also look into problems for or videos for the other subjects on our YouTube channel. And also remember to check out our Facebook, Twitter, and Instagram pages for any other updates. And please note that there might be changes in our schedule next week for our session. So just be on the lookout for that. Okay, just to make sure that you attend at the right time. So check out our social media pages. Okay. So from yesterday, we were doing this problem. Okay. Hope you still remember. So we can go quickly through it and then do another problem. Okay. So in this question, we were given a diagram. And then, like I said, most of the time we get our answers in our problem statement or in our, like the question sort of direct you to where you're supposed to get, okay? So we all have different problem solving skills. So whatever procedure you use, as long as it's mathematically correct, you will be fine. Okay. So from our diagram, we were given that, for example, we were given the equation of line SP. Okay. So we were given the equation of the line SP. We were also given the relationship between the line OS and OP. And then we were also given that RT so our RT is perpendicular to PS. Okay. And then we are showing that T cuts the y-axis. So we identified that our point T is a y-intercept. Okay. And from yesterday, we calculated the coordinates of P. So we could see that, okay, P is actually our y-intercept, and it's a y-intercept, which is on the line SP. Remember, line SP or PS is the same thing. So we could see that, oh, our point P is actually a, what's this? A y-intercept. And then we determined the coordinates of point P, and we saw that it's 0 and 1. Okay. And then so let me just write the coordinates of P because now we know them. So we have the coordinates of P as 0 and 1. Okay. So after identifying our coordinates of point P, we were also asked to calculate the value of our A because our equation of PS is given in terms of A, and then we need to find a number that we can substitute the value of A with. Okay, and then when we calculated that value of A, we saw that the value of A was 3. Okay. So we calculated the value of A by using the information that we have, knowing that our OP is 1 and relating it with the SP that it's given. And then we also got the coordinates of S as 3 and 0. So we also got the coordinates of point S, and that helped us to calculate our value of A. And then we found that our A equals to 3, okay? And then we also saw that, okay, there's actually more than one method of calculating our point A, okay? And then also for 4.3, we used our relationship of perpendicular lines because we know that our perpendicular lines, so we got our value of A as 3, and then we were supposed to determine the equation of RT in terms of Y equals to MX plus C. So we're supposed to determine RT using our equation and given that a equals to 3. So I hope you can see that. Remember when we calculated our a, it was actually 3. So you are already also given an answer from the question. Okay. And then we were supposed to calculate the coordinates of point R. And they said it is the point where line PS, okay, and line TR meet. Okay, so you are shown that the point PS, the point R, okay, it's the point where line PS and TR meet. And then what does that mean? Where lines meet, we can equate their equations, okay? So where lines meet, so you would have to find the equation of line TR, because remember from the previous one, we calculated the equation of line PS, isn't it? So from the previous, we calculated the length of line RT. So we know the equation of line RT, okay? And it's Y equals to, let's just quickly go there. So our equation is Y equals to, it's this one that's given, it's Y equals to 3x minus 5/2 over 3, isn't it? So this is the equation of line Z, okay? So when you have, let's go back. So when you have the equation of the line RT, because you were supposed to determine it here. So they said determine the equation of line RT. So when you have the equation of our line here, which is 3x minus 5/2 over 3. Okay, so when you have the equation of the line RT and you know the and you know the equation of line PS. Remember R, it's a point on line PS, isn't it? So if you have this equation of the line RT, which is perpendicular to PS, and R is a point of intersection, that simply means if you equate the equation of line PS and the equation of line RT, then you can solve for X and then determine your coordinates of point R. Okay. Does it make sense, guys? JJ, Wendy? So if you have the equation of this line, you can determine the equation of PS, which is already given. Okay, remember from our equation of PS or SP, we know that it's Y equals to negative. Remember when X moves to the other side, it will become negative. So it is negative 1 over A X, negative 1 over AX, and then when A goes to the other side, it will become positive, so plus 1. Okay, this is what we realized yesterday, that when you move a to the other side, it will become positive, and when you divide throughout by a, you get 1. Okay, so now we calculated our value of a, and our value of a is 3. So it means the equation of PS is equals to the equation, so it's going to be 1 over 3 x, okay, plus 1. Okay, so that's how you would get the equation for your line PS. And then to get the coordinates of point R, because it's a point of intersection, okay? So to get the coordinates of R, they simply saying you should find where the equation of PS equals to, so where the equation of line PS equals to the equation of line RT. Okay, so that's what you simply had to do. So you simply had to do, find the equation of PS, find the equation of RT, equate them, then solve for your X and Y. Okay, remember when you solve for your X, then you substitute it in one of the equations, then you are done. Okay, so let's quickly go through number 4.5 and 4.6 and do one more problem, because tomorrow we will look into new work. Okay, so for our 4.5, they said calculate the area of triangle PRT. Okay, so how do we calculate the area of a triangle? How do we calculate the area of a triangle, guys? Do you want to try, JJ, Wendy? The area of a triangle? Okay, so in this case, so it means even if you didn't get your, let's say you didn't get your 4.4, you could still do your 4.5. Okay, so in this case, they're saying that we need to calculate the area. Okay, so the area is simply, so area of a triangle, if you still remember. Thank you. So the area of a triangle will be half base times height. Okay, would be half our base times our height, isn't it? Okay, great. So half, which is our half base times height. So if we draw out our triangle, so remember we are given the coordinates of our R. Now we know the coordinates of our R. So it's 2 and 1 over 3. Okay. So now we know the coordinates of our R. And if we draw our triangle, ooh, sorry about that. We have our point R. We have our point P. And we have our point T, isn't it? So we know that we need a base and a height. Okay, so what would be our base in this case? So what would be our base in this case? Because we have a point R, P, okay. So our base, okay. So our base would be RT. Thank you, Wendy. And then our height and then our height would be PR. Okay, so now that you know your base and your height, remember, how are you going to find RT and PR? How are you going to find PR and RT? Which formula are we going to use? Are we going to use the gradient? Are we going to use the distance or midpoint? Which formula are we going to use? Thank you. We're going to use our distance formula. Okay, because we know that RT is a length, and then we also know that PR is a length. Okay, so you are going to use your distance formula to calculate your length of PR, your length of RT, and then you use your formula for half base times height, and then you get your area. Okay, so I hope you guys are fine with that. And then quickly, you are supposed to calculate and also give reasons the radius of a circle passing through points P, R, T. Okay, so if we let's say we remove that. So let's say now we draw a circle. So they say the circle has to go through P, R, and T. Okay. It's not gonna be very neat. Okay. So now we are supposed to calculate the radius. So we're supposed to calculate the radius of a circle, which is passing through our points P, R, and T. Okay, so what do you think is gonna help you to calculate this radius? Thank you, Wendy and JJ. Yes, for the previous one, you have to calculate the length using the distance formula. And then after calculating the length, then you get your area by saying half base times height. Okay, thank you so much. I can see that you understand. So with regards to this, now we have a circle that goes through point PRT, and they want us to calculate the radius of the circle. What is going to help us to calculate this radius? Look at the diagram carefully. Okay, so I hope you still remember that if you have a semicircle, because maybe on this diagram it's not very clear. Okay, so I hope you still remember this, because the angle that is, okay, this is supposed to go here. Okay. Okay. So the angle that is subtended by our diameter, because remember this is our diameter, isn't it? So if this is a semicircle, this would be our diameter. Okay. So this would be our diameter. And because the angle that is subtended to our semicircle is 90 degrees, then this is 180 degrees. And then that means this is our diameter. So if we relate this to our diagram, we will see that, oh, the length of PT is actually a diameter. Can you see that, guys? Okay, great. It's not really clear on the diagram, but then the length of your PT is actually your diameter. And if you have a diameter, how do you calculate your radius? Okay, remember we have a diameter. Okay, so you can, thank you, you can use the midpoint, or you can also use the relationship that your radius. Thank you for your answer, Wendy. Because yes, the radius is from the circumference to the center of your diameter. So you can use the midpoint of a line segment by using your coordinates. But then remember remember when you use the midpoint of a line segment, what are you going to get, Wendy? You are going to get the coordinates. So you're going to get your X and Y value of your so you're going to get your X and your Y value for your midpoint. And then which value are you going to use for your radius? So you can also use the relationship. Let's say you calculate your distance from P to T. So now you know your length, and then you will say your diameter divided by 2, because your radius is practically your diameter is your radius times 2. Okay, so when you find, let's say you use the midpoint, then you can use, because in this case, it's the length that's in the in the Y. Okay. Okay. So I hope you guys understand. But then I hope you can see that from all the problems that we've been doing since last week, we need to know how to calculate our gradient if we are given 2 points. Okay. And we also need to know, thank you, Wendy. So we still also need to know the relationship between the gradients of perpendicular lines and parallel lines. We need to know how to calculate our equation of a line using, if you have 1 point and a gradient, or you can also use y equals to mx plus c. If let's say you have a gradient and a y-intercept, because our value of c represents our y-intercept, we need to know how to use our distance formula carefully, making sure that we substitute correctly. If it's a negative value, we substitute correctly. And then we also have to remember how to use our theorem of Pythagoras, knowing that, for example, our AB is the longest side, which is opposite our hypotenuse. And then our midpoint of a line segment. Okay, so let's say, I hope you guys know how to use all these formulas. And also remember to know your properties of your quadrilaterals and your triangles. Okay, so if we just do one problem quickly, then tomorrow we can start with new work. Okay, so tomorrow we're gonna start with inclination. Okay, because if you realize from the problems that we've been doing, we've been only focusing on the length, but less on the angle. Okay, so now we're gonna include the angle, like determining the angles. Okay, so for example, remember guys, if you still wanna go through the question paper that we were doing, so at your own time, if you still want to go through the question paper we were doing, just go through to the DBE website and look for grade 11 material. Okay, so it's a 2015 November exam. There's more exams, and please look into that, because they also have solutions. Okay, so you can also compare your solutions. Okay, so let's quickly look into this one before we start new work tomorrow. So this is an exemplar, also from the DBE from 2013. Okay, so the line of questioning doesn't really change much. Okay, so like always, we always read our statement first. For example, in this case, they gave us a diagram. Okay, and then, like I said, guys, remember to revise your properties, because you won't be given, for example, properties of a parallelogram, a kite, and all that. So you need to know them. Okay. So in this diagram, you're given a point with the coordinates. You also have Q, S, and most importantly, you are given that it is a parallelogram. Okay. So if they state in the given that it's a parallelogram, it means you can use properties of a parallelogram. Okay, so it means you can use properties of a parallelogram when you solve your problem. Okay, and then they say the sides of OS. Okay, I will highlight my OS. So they say in the side of OS, and OQ, so OS and OQ, the sides of OS and OQ. So are defined by equations y equals. So respectively simply means OS, it's the first one. Okay. So OS given by the equation y equals to 6x, and the equation of OQ, let's use a different color. And OQ, and then they gave you the equation equals to minus x. Okay. And then they gave you an angle, okay, that you don't know what it is. But then they say determine the equation of QP in this form. Okay, so you are supposed to calculate or determine the equation of QP. Okay, so from the statement alone, guys, like I said, the question always has the answer. So you are given the equation of this line, and you are not given the equation of this line. But what is the relationship of line PQ and SO? How can you relate PQ and OS using properties of a parallelogram? Remember, the answer sort of hints, the given sort of hints answers. Okay, so if we were to look at properties of a parallelogram, okay, remember to determine the equation of a line, you can use this. By then, to determine the equation of line PQ, you need a point. So that's sorted. We have a point, which is point P. Can you see that? Thank you. Thank you, Wendy. We have PQ. Let me use a different color. We have our we have our PQ, which is parallel our OS, isn't it? And then remember I said to determine the equation, you simply need a point. We have a point. How are you going to get the gradient? Thank you. And they are also equal in length. Okay. So how are we going to find the gradient of PQ? Okay. What is the gradient of line OS? So we have OS being parallel to PQ, and we also know that their lengths are the same. But what will help us to determine the line of PQ is the gradient. Okay, so the gradient of what? Parallel lines. Okay, so if we try to find our gradient in the line of OS, it means we will find the remaining unknown, because we know Y1 is 17 and we know X1 is -3. Okay, so we know that this is -3. Don't forget, So this is a 3, guys. Don't forget to put this negative sign in front of the -3. Okay, so we know that our x is -3. We know that our y is +17. But then we are struggling to find this gradient. But then the interesting thing is that we know the gradient of OS. So the gradient of OS is what? It's 6. Can you see that? Because this equation is in the form y equals to mx plus c. Okay, and our c in this case is 0. So if we relate these equations, we can see, oh, that's the x, oh, that's the gradient. So the gradient of our equation is actually equal to 6. Okay, so if you have the gradient, then you can simply solve for y and you get your equation. Okay, so do you guys understand? Okay, great. Thank you. So you will have your equation of PQ. So we know how to do this one. And then in this case, they say, now determine the coordinates of Q. If you look at point Q, what's happening at point Q? What's happening at point Q, guys? You have your line PQ intersecting with line OQ. Can you see that? So at point Q, you have your PQ intersecting with your OQ. Okay, so to determine the coordinates of point Q, you are given this equation. So from the statement, you were given the equation of, so you were given the equation, which is minus x. And already you calculated, from the first question, you calculated the equation of PQ. So you're simply gonna say the equation of your y for OS OQ. Sorry about that. Equals to, so y of OQ equals to y of PQ. Okay, at point Q. Okay. Then after that, you solve for your x and y. And quickly for your length, if they say calculate the length of OQ. So how do you calculate the length? How do you calculate the length, guys? Quick one. Thank you. We use the distance formula. Okay. So from tomorrow, we're gonna do angle of inclination. Then we will know how to determine this angle and other angles when we are given enough information. Okay. So we will do this question again, but then we'll learn something new tomorrow, and then we will learn how to calculate that angle. So guys, please, if you still have questions, thank you so much for participating today. And thanks for making time to attend. And you may send me questions and I will attend to that. Thank you, JJ and Wendy. Really appreciate it, guys. Okay, so that's how you solve this problem. So read your statement carefully, find the relationships, use your properties of quadrilaterals and triangles, and then you are sorted. Okay. So if you still need help, or if you still don't understand, then send me an email. Okay, so I'll see you guys